Hello, hi, my dear friends. Sequence series now on trends. 15 minutes daily here spent. Believe me, before exam, I will end. So again, welcome you all to this lecture series of sequence and series. So in the last class, we discussed something about sandwich theorem. And if you are facing any difficulties and if you are getting any doubt, you are free to ask in the comment section, and I will try to sort it out as early as possible. So from the very beginning class, we already discussed a sequence when it will be convergent, divergent. Means in everywhere we talked about sequence. So is there any another way to know my sequence is convergent or divergent? Yes, of course. There is also another way is there. So I am introducing a new topic here that is called subsequence. That is called subsequence. This is nothing new to you. You already studied subset, set, subset. What is subset? If this is a big set is there, if this is a big set, and there is another set which all the elements are present in this big set, then I will call this set as subset. I will call this set as subset of this big set. Yes. In the same fashion, if there is a sequence, like 1, 2, 3, 4, 5, like this, and what is subsequence? If all the terms of this subsequence are present in this big sequence, then I will call this a subsequence. But subject to, there is also another condition. What is that another condition? Here in sequence, the order is important. Means if my subsequence this contains these three terms 1, 3, 5. Let's suppose, then in subsequence also it will remain as 1, 3, 5. You can't write 3, 1, 5. You can't write 5, 3, 1. Understood? Means in sequence the order is very much important, not the numbers. Remember this one thing. So for subsequence, all the terms should be in this set, be in this sequence, and the order must be same as the sequence. So let's do one two example for much clear on this. Suppose my sequence is like 1, 2, 3, 4, 5, 6, 7, 8 like this. So I can divide this sequence as two subsequences. One is like all the even terms, one is all the odd terms. If one sequence like 1, 3, 5, 7, 9, another sequence like 2, 4, 6, 8, 10. Understood? Let's suppose another example. 1 minus 1, 1 minus 1, 1 minus 1. I can also divide it in two sequences. Like 1, 1, 1, 1. Another is minus 1, minus 1, minus 1, minus 1. Understood? Subsequence means all the terms should remain in the big sequence, and the order should be same as in the sequence. So this is for understanding. Let's go to the book's definition for understanding. So remember the thing, the order should be same as in the sequence. So suppose my xn is my sequence, or you can take an. We took an from the very first class. So what is my sequence then? A1, A2, A3, A4, A5. Okay. Consider suppose this is at N1, this is at N2, suppose this is my A6, this is my N3, okay, and the sequence which is created by this xn1, don't write x, I am writing a n. The sequence created by an1, an2, an3 means a1, a3, a6. It is my subsequence. Understood? Understood, na? And see here, my n1 should be less than n2, should be less than n3. Similarly, it should be less than n4 up to nk. Why this is less than? For representing the order. The order should be same. It can't be a decreasing sequence. It should be monotonically increasing or straightly increasing sequence. Always n2 should be greater than n1. You can't go that side. You have to always go this side, because order is more important in this sequence. I hope this is clear. And there is one simple thing Suppose my sequence xn or an is converging to A, then my subsequence, what is that? Ank. Here is the my subsequence. I will write Ank. Okay, this will also converge to A. Let's understand. Suppose this is my sequence. This all the terms are lying within the interval. This is my A. This is my A minus epsilon to A plus epsilon. It is for all n greater than equal to m. Yes. So all the after all the n greater than equal to m, all terms are lying here. And this subsequence also part of this sequence, na? So this will also converge to here. And means all the terms, not all the terms, after all k greater than equal to m or nk will lies here. Means suppose this is a C and the big rivers are converging to C, to this C. Will not this small river will also converge to this C? Yes, this small river will also converge to this C. Understood? If my whole sequence is converging, the subsequence is also part of that sequence. So this will also converge. So you need proof of this, what I said. This subsequence also converge to the same. Suppose my sequence is converging to x. That means, suppose xn is my sequence. It is converging to x. Means I can say my xn minus x mod is less than epsilon for all n greater than equal to m. And by induction I can prove my nk is greater than equal to k. If I will choose my k greater than equal to m, then if I choose this, I can write nk is greater than equal to k is greater than equal to m. That means nk is greater than equal to m. Okay, that means my xnk minus x is less than epsilon. See here, it is valid for all n greater than equal to m. Na? Nk is also greater than m. You can put here nk. Nk plus 1, nk plus 2, but I need nk. So my sequence, my subsequence will also converge to x. Clear? If it is clear, let's write some notes. Let's write some notes. When will my sequence will be divergent? When will be my sequence will be divergent? Okay. So there are three possible cases. In that case only my sequence will be divergent. First case we already studied. If my sequence is unbounded, then my sequence is divergent. Understood na? Second thing, this I already explained. We already studied before class. So second thing, if my sequence has a divergent subsequence, means suppose this is my sequence. Suppose this is my sequence. There is some diverging subsequence. Suppose these terms are the terms of the subsequence, and these terms are diverging. That means, and don't think in a subsequence only finite terms are there. In a subsequence also infinite terms are there. Means if these terms are diverging, so this many infinitely many terms are left outside of this interval. That means my sequence will be divergent. So if any divergent subsequence exists, then my sequence is also divergent. What is the third case? What is the third possible case? Suppose this is my sequence. Let's say this black one is one subsequence. This red one is another subsequence. Suppose this red are converging to this number, any number, A, B, C, X, Y, Z. You can assume anything. And suppose this black subsequence is converging to another number, then you can say my sequence is divergent, because you studied it can't, a sequence has only one limit. A sequence can't have two limits, so it is divergent. So if a sequence has two convergent subsequence with different limits, with different limits, then also my sequence is divergent. These are the three possible cases when you can say my sequence is divergent. So let's solve some examples. Let's consider the sequence 1 minus 1, 1 minus 1, 1 minus 1. Okay, we solve this and we show this sequence is divergent. Let me prove this by using this subsequence concept. I can divide this sequence as two subsequences. One is 1, 1, 1 like this, and this is minus 1, minus 1, minus 1. See, this sequence will converge to 1 because all the terms are 1. It is a constant sequence. This subsequence will converge to minus 1. See, this third case. There are two convergent subsequences with two different limits. So my sequence is, this sequence will be divergent. Okay? Let's suppose another sequence 1, 2, 1 by 2, 3, 1 by 3, 4, 1 by 4, 5, 1 by 5. This is my sequence. I can also divide it into two subsequences. One is 1, 2, 3, 4. Another, let's say 1 by 2, 1 by 3, 1 by 4, 1 by 5. So we know this sequence is divergent. This sequence is divergent because it is unbounded. It is not bounded above. And this sequence is convergent and will converge to 0. So this sequence has a divergent subsequence. See this case too. So this sequence is also divergent. Clear? Let's see another example. Suppose my sequence an equal to n pi cos n pi. Okay, we know what is the value of cos n pi. Cos n pi is minus 1 to the power n. Na? If you put to 0, then it will be 1. If you put 1 in place of n, you will get minus 1. So it will be minus 1 power n. So I can write here it is equal to minus n pi or n pi, minus n pi if n is odd or n pi if n is even. Means if it is odd, my sequence will converge to minus infinity. If it is even, my sequence will converge to infinity. So my sequence is divergent. Understood? So let's see another theorem or result. Simple things. Suppose my sequence is an. If all the even terms of the sequence are converging to a number, so let's say a, and also all the odd terms of the sequence are converging to the same number a. This is my sequence. Let's say this red are odd one and this black are even one, and all the reds as well as all the blacks subsequences are converging to same number. Then you can say that overall my sequence is converging to this same number a. Okay, so let's prove one thing by using this. Let's suppose my an equal to minus 1 to the power n by n. Okay, so consider my all even subsequence. If it is even subsequence, it will be, I am writing here, it will be 1 by n or minus 1 by n. If n is even, it will be minus 1 by n if n is odd. See here, if n is even, then my n will be 0, 1 by infinity. If it is odd, then my sequence will converge to, minus 1 by infinity. It will be 0, not minus 0. Okay, so when it is odd, it is 0. When it is even, it is 0. When it is odd, it is also 0. So my sequence will converge to 0. So by using this concept, clear? So now let us read. In some cases, my limit is converging to infinity, not converging. My limit is going to infinity. So what will be the definition of that? Definition when my limit is equal to infinity. Means when you can say my an tends to infinity, or limit n tends to infinity, an equal to infinity. So when can you say? Suppose my sequence an is there. All the terms are like a1, a2, a3, a4 like this. If I am assuming any number if I am assuming any number, let's say k, if all the terms are greater than this, then I will say my sequence is converging to infinity. Did not understand? Let's say my k is, I am assuming k as 5. If all the terms are greater than 5, okay. I am assuming, and k is any random number that is not constant, that is not fixed. You can assume any number. Let I am assuming k as 100. Then all the terms should greater than 100. Let my k is 1 lakh. All the terms should greater than 1 lakh. If my k is 1 crore, then all the terms should be greater than 1 crore. I am saying here all the terms, that does not mean all from 1 to infinity. That is for all n greater than equal to m. Okay. For all n greater than equal to m. If for all n greater than equal to m, all the terms are greater than any number you can take, then you can say my sequence is converging to infinity, or my limit of the sequence is infinity. Understood? If for every k, what can you write? What is k? K is any natural number. K is any natural number. My an is greater than equal to k. For all n greater than equal to m. Understood? For all n greater than equal to m. And just one thing, this k is not natural number. Can be any number. K is not natural number. K can be any real number, anything. It is not natural number. K you can take anything. And also same thing, opposite case, when you will say my an is converting to minus infinity, if you take any number k, if my all the terms of the sequence after all n greater than equal to m is less than k, if my an is less than equal to k, then you will say my sequence is converging, my limit of sequence is equal to minus infinity. Suppose if we take k equal to minus 10,000, means all the terms after all n greater than equal to n should be less than minus 10,000. Then take k equal to minus 1,000 crore, then all the terms should be less than this, means all my sequence, limit of sequence is equal to minus infinity. So let's solve one example based on this. You have to prove limit n tends to infinity, b to the power n equal to infinity for all n greater than 1. Sorry, for all b greater than 1. Okay. So let assume any m. Let assume any k which is greater than 0. Okay. So what you have to prove? You have to prove this b to the power n, am should be greater than k. It should be greater than k. So for all n greater than equal to m, take logarithm both side. You have to choose n. N ln b should be greater than ln k. N should be greater than ln k by ln b. So you have to choose this n. So choose m which is greater than ln k by ln b. Understood? And as you know, n is greater than equal to m which is greater than ln k by ln b. So what happened? My n is greater than ln k by ln b. Proved. This one proved, na? You can go this side. So my bn is greater than k. So my sequence is, my limit of sequence is equal to infinity. Hope you all people get it what I explained today. So see you in the next video. Till then, goodbye. Tata. Keep studying and keep asking in your doubts in the comment section. Goodbye.